Um, so I sent you some problems on your Gmail.
Okay, let's have a look. There they are. I even figured out how to handle these.
Yeah, so for this you just have to find the measure of the angle.
Okay, hold on a minute. By that I meant I figured out how to zoom. First of all, I got to download it. Okay. And now, hold on a minute. It's a little tedious, but I'll have it in a second here. I got to open it in Paint. That's what I finally figured out, is if I open it in Paint, where's the open with? How come it doesn't let me open with? Open with Paint. Alright. Now, let's see. I need to zoom down. There we go. Alright. Whoops. I forgot that you can write. I don't need my writing tool, but I'd like to use it anyway. I can't see the top. What's it looking for? Find what?
The measure of the angle.
The total one?
Yeah.
Am I missing some information here? I mean, how do I know what that angle, that little one is?
The one on like the side is 80 degrees.
Oh, okay. I didn't see that at first. Here, let's label that. So this one is 80, correct?
Yeah.
Okay, so how much is this one right here? It's complementary with 80. What's complementary with 80? Complementary. 10.
Oh, yeah. Okay. Yeah.
Okay, so that angle is 10. Okay, now let's start from the beginning. That's 360.
Mm-hmm.
There's another 270. So we got 360 plus 270 plus 10.
Yep.
740. Did they want it in degrees? I presume they did, since they gave you the 80 in degrees.
Yeah, they did.
Okay. So, let's have a look at the other one. Can't do that. I gotta do this. And what's that? That angle? What is that angle?
It's 80 again.
Oh, it's 80 also.
Yeah.
Okay. So if that's 80, what's that? Fit. What's this angle?
Um,
In any XY coordinate plane system, all these angles are right angles.
yeah, 90.
Okay. So, the only reason this is a hard problem, so that part of it, is it plus or minus 90?
Minus 90.
And the same direction, another 80 gives you what?
Negative 170.
Okay. And that's the correct answer. Now, that happens to be coterminal with a 190 degree angle. In other words, if I were to have drawn it like this, that angle is going to be 190.
Mm-hmm.
So it's coterminal, multiple of 360.
Okay.
Okay. Is this the only two problems you sent me?
Yeah, but can I send you some more?
Sure. Um, yeah, I'll get a little bit faster at doing them. Go ahead and send them one at a time. Boy, I've noticed lately, even when I'm sending photos from my phone to my computer, it can take like 15 minutes. If I send like 4 photos,
Mm-hmm.
take pictures of my garden or something, and I want to put it on my computer, that's the way I do it. So it really makes a difference on how many files you attach.
Okay, I think it's sent.
Okay. And maybe while I'm doing all my things to get this thing open, you could send another one.
Okay.
Because me getting this open is just a little tricky. I'm not sure I need to open this in Paint. I can work with this right here. All right, should we do number 4?
Yeah.
What's this measurement? 80 again?
It's 70.
We're looking at this top figure, right? Which must be...
No, we just did that one.
Oh, you're right, we did. So we're looking at 5. Okay, so this angle is
Yep.
70. Okay. And they want the measure of the total angle. So what's this tiny one here that is complementary with 70?
20.
Okay. So let's just go around the horn. This time we're going negatively. We're going clockwise, which is a negative direction when it comes to angles. So that is how much?
360.
Minus. And then we're going to go another minus 180. And since we're still going clockwise, we're going another minus 20. Minus 560.
Yeah.
And again, if they wanted a positive angle that was the same as that, in terms of trig, in other words, in terms of trig, everything that is coterminal gives you the same trig answers. In other words, the sine of 30 degrees is the same as the sine of 390 degrees, the same as the sine of 750 degrees. You see what I'm saying?
Yep.
And so you tend to, it's not really correct to think of those as being the same angle. They're not. But for trig purposes, it results in all of the same trig function values.
Yeah.
Okay, that's all on this one?
I sent you another one.
Okay. Let's see whether I can blow that up at all. Yeah, just enough that I can read it. Nope. Okay, I got it enough that I can read it though, so it works. Okay, so this angle is 40, right?
Yeah.
So what's this angle right here?
50.
These aren't complementary anymore, they're supplementary.
Oh.
This is a linear pair. That's what we're looking, well, we're looking at this one. One is supplementary to two, meaning they have to add to 180.
Mm-hmm.
So what's two?
140.
Okay. All right. I guess it doesn't. Is this the next one?
Yeah.
11?
Mm-hmm.
Okay. Pretty simple stuff. This is very basic geometry, really. Okay, this is a little more complicated. Well, did I label that properly? Yeah, 115 degrees. Did they give you any information about that?
No.
No, they don't, but you don't need it. We'll just call that X. It's going to be a positive angle, okay? So, what's this measurement right here?
Um, 270.
Well, it's 270 plus X, right?
Yeah.
So that line is 270 plus X, that angle. And what are they looking for?
The measure of the
X?
angle.
What are they looking for?
The measure of the angle.
Oh, okay. All right. I think I understand this now. Okay, let's go back here for a moment. What is the measurement? They're telling us, this is easy also. I'm overthinking it. So if that whole thing is 115, what is X?
Um,
Remember, these are all 90-degree angles. The XY coordinate system is always perpendicular to one another.
okay. 25.
Right. Now, in terms of this angle, that's 25 degrees. I don't need to put a positive or a negative sign on it. That's a 25-degree angle.
Okay.
Okay? Now, the angle they want to know is this one, and that is counterclockwise, so that does need a sign on it. So it's 270 plus 25.
Okay,
Because
yeah.
we're going in a counterclockwise direction. It's all positive.
Okay.
Okay?
Okay, now I'm just gonna verbalize problems.
Okay.
Okay, so the first one is tan of theta equals negative 15 over 8 given that theta is in quadrant 2.
Okay, what do they want to know?
And you have to find all the trigonometric functions for each angle theta.
Okay, there are a lot of trig problems that always begin the same way. You know what that way is?
Making a triangle.
You got it. It's going to turn these problems into such easy problems you won't believe it. And doing what? Making a right triangle, first of all.
Okay.
Because these trig functions, these ratios, SOHCAHTOA only applies to right triangles.
Mm-hmm.
But the second part is drawing a triangle and labeling theta. Because I could put theta down there, or I could put theta up at the top.
Yeah.
So it's important to do both. Now, step number 2 is what?
Labeling -15 and 8.
Well, take off the sign. We're going to use that sign, but only not in the initial part of it.
Okay.
We know that this side, first of all, the sides of the triangle don't have a negative sign ever. Okay? So I can label 15 and 8.
Okay.
The tangent of theta would be 15 over 8 if it was in the first quadrant. Well, it's still 15 over 8, but it's in quadrant number 2. And you're going to see what's happening here. What's the hypotenuse?
17.
Yeah. Now, we can easily find all trig functions of theta. Once we have the triangle labeled, so what's the sine of theta? And we don't need to know what theta is, ever. So the way I do trig is I always come up with an absolute value ratio first, and then I put the plus or minus sign on it last, always. Just, it flows in my mind much better when you do it that way.
Okay.
Okay, so what is the sine of theta from this triangle?
15 over 17.
Now, what is the plus or minus on sine in the second quadrant?
It's positive.
Okay. Cosine of theta is what?
8 over 17.
What is the cosine plus or minus in second quadrant?
It's negative.
What is cotangent of theta? Remember, it's the reciprocal of tangent.
8 over 15.
Yeah, now in this case, I go ahead and do the whole thing at once because I know it's just the reciprocal of that number. So it's going to have the same sign as tangent.
Yeah.
But also cotangent's negative in quadrant 2 also. How about the last two are secant of theta and cosecant of theta. So, secant is reciprocal with what?
Cosine.
So what's the answer?
-17 over 8.
And cosecant, reciprocal to?
Sine, so 17 over 15.
There you have it. And that's the way you do every problem like that. And they won't always tell you from the second quadrant. They might say, cosine is negative. And between tangent being negative and cosine being negative, that's the same as telling you it's in the second quadrant.
Okay.
Okay? They might say this. Theta is greater than pi over 2 and less than pi. That's in the second quadrant.
Okay.
So whatever other piece of information they give you, that's going to be enough to tell you what quadrant it's in. So when I draw this triangle, I'm not paying any attention to which quadrant it's in. I'm doing everything based on the first quadrant. Then I'm adjusting the plus and minus signs based on what quadrant it's in.
Oh, okay, I see.
Okay? In other words, I don't draw this triangle. I know it's in the second quadrant, but I don't draw the triangle like this.
Okay.
Okay? I always draw it. It's just if you always draw your triangle like this and label theta down on the lower right, it gets systematic and you'll be able to do all of these easy as pie.
Okay.
What else?
Okay, so this one's kind of similar again.
Okay.
So it's cosine of theta equals -3/5, given that theta is in quadrant 3.
Okay. Work me through it.
So first you draw a right triangle. And so you would label that 5 and
Oh, you
-3.
got to label theta. I got two choices for theta. I don't always have to put theta in the bottom right. I can put theta up here and the problem will work just fine.
Oh, yeah.
But you got to know where it is.
Yeah, so bottom right.
Okay. Either one works. I just am used to using bottom right. Okay, now dimension as much of that triangle as you can.
Okay, so it would be 3 and 5. So 3 on the, yeah.
Now
Uh,
dimension the rest of it. You will always be able to dimension the third side.
4.
Now let's go through all of them. It's the sine of theta.
The sine of theta is 3/4.
No, sine is opposite over hypotenuse.
Oh yeah, 3/5.
That's why it's important to label that thing. Because if you don't put
Yeah.
theta in there, then you're going to get all confused. Okay, so it's 4/5. What's its plus or minus sign? And the third quadrant.
It's negative.
Tangent of theta.
3/4.
No.
4/3. 4/3.
And its plus or minus sign?
It's positive.
Okay. Okay, now the other three, we don't really need the triangle, do we?
No.
In other words, the secant of theta is what?
-5/2.
5/3. Yeah, that's a 3.
Yeah, okay.
And the cosecant of theta is what?
-5/4.
And the cotangent of theta.
3/4.
Yeah. So you really only need the triangle for the three, I call them primary trig functions. There's nothing really primary about them. Other than the old calculators, those would be the only three keys you would have. You have an Inspire or a TI-84?
TI-84.
So those are the only three keys you have. If you want to figure out the secant, you have to take the reciprocal of whatever you get for the cosine. Don't you? I think so. I don't think there's a blue key, is there, for those other three functions?
No.
Okay. So that's how you get the, in other words, if they want to know the secant of 70 degrees, you look up the cosine of 70 degrees, and then you 1 divided by that answer.
Okay, yeah.
In other words, here's what I'm saying. It might not be absolutely obvious, but 1 over the cosine of 70 degrees equals the secant of 70 degrees.
Yeah.
All right. What else you got?
Okay, so this one is cosecant theta equals 2, given that theta is in quadrant 2.
Marginally more difficult, but not really. Always remember, trig function of theta equals a ratio.
Okay.
So instead of 2, let's write that 2 over 1.
Oh, okay.
Now you can put two dimensions on that triangle.
Mm-hmm.
Where do they go?
So the 2 goes on the hypotenuse. And then the 1 goes on the bottom.
No. Cosecant is reciprocal of sine.
Oh, yeah.
So the sine of theta would be 1/2. That means the cosecant of theta is 2 over 1.
Mm-hmm.
Now what's the bottom?
Root 3.
Yeah, I was going to say you should recognize this triangle. This is a 30, 60, 90 triangle.
Mm-hmm.
Okay. And then they want all the other 6?
Yeah.
Do we need to go through it, or you know how to do it?
No, I can do that part.
Okay. Let's tackle some stuff maybe that you don't know how to do. The only tricky part of that was they didn't give you the 1.
Yeah. Okay, so this one says secant of theta equals -4, given that sine of theta is greater than 0.
Good. These are the kind I was talking about, where they make it marginally harder. Now, between those two pieces of information, you can figure out what quadrant theta is in. Sine is positive in which 2 quadrants?
1 and 2.
Secant is positive in 1, right?
Mm-hmm.
So which quadrant are we in?
We're in quadrant 1.
Secant is positive. All 6 trig functions are positive in quadrant 1. So we're not in quadrant 1 if the secant of theta is equal to -4.
Oh.
So again, what 2 possible quadrants can we be in if sine of theta is greater than 0?
1 and 2.
1 or 2.
Mm-hmm.
And this tells us we got to be in 2.
Okay.
Because secant is negative in 2 and sine is positive in 2.
Oh, okay.
Whereas in 1, secant would have been positive.
Okay.
So it's in 2. So instead of just telling you it's in 2, they gave you this information and you have to deduce that it's in 2. Let's get our triangle labeled before we go to the next one.
Mm-hmm.
Label it.
So it'd be -4 over 1.
No negative signs in that triangle. There are no dimensions that are negative.
So -4 would be the hypotenuse? Or 4?
There are no negative signs in those dimensions.
Yeah, and then 1 would be like the side.
In other words, secant goes with cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. Okay, what's opposite theta? What's that dimension?
Root 15.
Good. I love how fast you can do those because you've learned that you don't start with a squared plus b squared equals c squared, right?
Mm-hmm.
You go straight to c squared minus a squared, the square root of c squared minus a squared.
Mm-hmm.
Okay. Now, you can do the rest of it?
Yep.
Okay.
This one is cosine of theta equals root 5 over 8, given that tan of theta is less than 0.
What quadrant are we in?
So we're gonna be in quadrant
You can do this either way, but what two quadrants can tangent be? Let's do this. There's a better way to do it than I did it last time. First of all, where is quadrant negative or tan negative?
Tan is negative in 2 and 4.
2 or 4?
Yeah.
Well, 2 and 4 is actually correct. And cosine is positive in what two quadrants?
Cosine is positive in 1 and 4.
So what quadrant are we in?
4.
Correct. That's the way to do it.
Okay, yeah.
Over here. Just figure out which two tan can be in, which two can cosine be in. Whichever the common quadrant is, that's what quadrant you're in.
Okay.
So theta is in 4. Label it.
So the bottom part's going to be 8.
Nope. SOHCAHTOA. Get SOHCAHTOA memorized like you know your name. I like to say to people, you don't memorize trig. You know it like you know your name. You don't have your name memorized. You know it.
Okay, so the bottom part's going to be root 5.
These trig functions. You need to get instantaneous where you know which two sides it's talking about.
Okay, so the bottom part's going to be root 5. And the hypotenuse is going to be 8.
Okay, this other side?
Root 59.
Good. Now you can do everything else, I think.
Yep.
In other words, once we've figured that out and drawn the triangle and fully dimensioned it, then as long as you remember all students take calculus. Were you taught that? Did I teach you this?
Yeah.
Okay. Then this is pretty good for figuring out the plus or minus sign.
Mm-hmm. Yeah.
And everything. Okay? You got any problems like this?
No.
Okay. How would you do that problem? Actually, I didn't really do it properly. Okay, if you don't have any, I won't go through it. In other words, you don't need material, right? You got plenty?
Yeah.
Okay.
Okay, so this one's kind of different.
Okay.
So you have to find the exact values of the 6 trigonometric functions.
Okay.
And so it gives it as 300 degrees.
I don't know what you mean.
So it gives
all 6 trig functions of 300 degrees?
Yeah.
Oh, okay.
No. It gives you an angle 300 degrees. And then you have to find the 6 trigonometric functions for each angle.
No. So you're talking about, there's my 300 degree angle. It's a 270 plus 30, right?
Mm-hmm.
And it wants all 6 trig functions of 300 degrees, right?
Yep.
Let me tell you how I do these. From your unit circle, these formulas give you your reference angle. And your reference angle is that first degree or first quadrant angle. So when I'm trying to find the sine of 300 degrees, I put in parentheses what its reference angle is. What is it?
Uh, mm,
Plug it into this fourth quadrant. First of all, which quadrant is it in?
it's in the fourth.
Okay, so plug it in that fourth formula.
So it'd be 60 degrees.
Right. And now, what's the sine of 60?
The sine of 60 would be root 2 over 2.
Root 3 over 2.
Or root 3 over 2, yeah.
And now what's its plus or minus sign? Always my last step.
It'd be minus sine.
Let's do cosine of 300. All of these reference angles are going to be the same, incidentally. In other words, it's going to be the tan of 300 is the same as the tan of 60. I shouldn't say the same as, but what I have in parentheses is the reference angle or the equivalent first quadrant angle. In other words, you're going to get the number part from what I got in parentheses. What's cosine of 60?
Cosine of 60 is 1/2.
What's its plus or minus sign?
It's negative. No, it's positive.
All students take calculus. So it's plus tangent of 60.
Tangent of 60 would be root 3.
Hold on. Yeah. Root 3 over 1, okay? What's its plus or minus sign?
Negative.
And I assume you can do the other three by just taking the reciprocal. That's all you need to do. You don't even need to figure them out.
Yeah.
In other words, secant is negative 2 over root 3. Let's talk about that for a second. Tell me if your teacher is okay with you doing it this way, where you do not rationalize your answers. In other words, because this comes out to be this, right?
Mm-hmm.
Does he allow that answer?
No. She wants us to rationalize.
No kidding. Wow. That's terrible. Okay. You know how to rationalize?
Yeah, I do.
Okay. When I say it's terrible, I don't mean it's terrible teaching or anything. It's just, it makes trig a lot easier if you don't have to worry about doing all those rationalizations. And you are frequently looking at reciprocals where, in other words, the sine didn't need rationalizing. Secant did. If we were asked the secant first and we rationalize it, now getting the sine is harder.
Yeah.
Notice what the secant becomes after I rationalize it. It becomes minus 2 root 3 over 3, right? Now, if I hadn't started with the sine and I wanted to know what sine is, well, now I got minus 3 over 2 root 3. I got to rationalize that, and that's harder to rationalize than it was to begin with.
Yep.
More numbers. So there's a lot of logic in not forcing students to rationalize answers on trig. Besides that, these two are the same number. They are not different numbers.
Yep.
Only one reason math wants you to rationalize it, because you're taught to think of division as being dividing into equal number of parts. If you do 1/3 of a pie, you're dividing that pie into thirds. Well, how do you divide something into or by an irrational number? You can't do it.
Yep.
So conceptually, I get why math does that, but most people make exceptions when they get to trig. Okay, what else do you got?
Okay, so this one, I have to sketch the right triangle.
Okay.
And so it says sine of theta equals 5 over 13 and tan of theta is less than 0.
Same problem. You see, it's no different than the others. Where is tan of theta? What two quadrants is tan of theta equal to 0? Or less than 0?
Um, 2 and 4.
How about sine theta? Where is
Sine.
it positive? Yeah. In other words, we've been told it's positive.
Yeah. So 1 and 2.
So what quadrant are we in?
2.
Correct. So they're just making you do one extra step.
Mm-hmm.
This one they actually tell you to draw the triangle, and they didn't tell you to do that in the other ones?
No.
Huh. Because you notice that we're doing this exactly the way we've done them all.
Yeah.
Dimension this?
So the side part would be 5 and the hypotenuse would be 13.
Well, the hypotenuse is 13, but you keep getting tripped up on your SOHCAHTOA. And I don't want you to make a mistake. Okay? That's opposite over hypotenuse. That's adjacent over hypotenuse. That's opposite over adjacent. And when
Yeah.
they say the adjacent, they mean there's always two sides that are adjacent to any angle. They are always referring to the adjacent side that is not the hypotenuse.
Mm-hmm. Yeah.
Okay? So opposite, that's where you start.
Yeah. So
Wow.
that'd be
Hypotenuse next, 13. What's the bottom?
12.
Uh-huh. And the rest of it you know how to do.
Yep.
Okay. What else?
Okay. So this one is y equals negative 3/4 x and x is less than 0.
What? What are we supposed to do here?
Sketch another triangle.
Sketch it as a triangle. Really?
Yeah.
That's a linear equation. Let's see what they mean. In other words, incidentally, your unit circle is your introduction to polar coordinates. Polar coordinates can be put onto rectangular coordinates. Okay? So, let's just see if we can graph that. That's a slope of minus 3/4 going through the origin. So, that's like that. Okay. Think I got an idea of what they're talking about now. So, what they're saying is, there's our reference angle right there.
Mm-hmm.
But what we want is that angle, correct? All 6 trig functions of that angle?
Mm-hmm.
Okay. So, if the slope is minus 3/4, slope is rise over run. There's the rise, there's the run.
Mm-hmm.
That's a 3, 4, 5 triangle again. Now, they taught you inverse trig function?
Yeah, they did.
Okay, because I think we need it here. In other words, we need to figure out theta, right?
Yep.
Well, I can figure out theta. Theta, remember that when you use inverse trig functions, you're solving for angles.
Mm-hmm.
You're taking inverse trig functions of the ratio, and that's going to give you the angle. If you do that in your calculator, you get approximately 37 degrees.
Okay.
I don't know if he wants you to round it off or not, but for our sake, we'll just use whole numbers.
Okay.
What does that make x? Now, not x. X is not a good word to use. I don't want to call it theta because we're already using theta. Let's call it alpha.
Okay.
If theta is 37 degrees, what's alpha?
143.
Okay. So alpha, supplementary to theta. But now notice what's going to happen. When you go do all your 6 trig functions, notice why x is less than 0. We're going to the left to measure x.
Oh, yeah.
X in this case would be minus 4. In other words, if I have to put coordinates on that point right there, it's minus 4 plus 3.
Okay.
Why sine is positive in the second quadrant is because it's 3 over plus 5. And incidentally, when you're talking about polar, the hypotenuse is always positive no matter what quadrant it's in. But you use the sign of the x and the y based on whether they're positive or negative.
Okay.
Okay? And you can see that if I was in the third quadrant, x would be negative, y would be negative. Since tangent is 1 over the other, it turns out to be positive. So if I go to find all 6 trig functions, I'll start with sine. What's the first thing I do? Convert it to its reference angle. What's its reference angle?
That's
theta.
37.
Right. In other words, now take the sine. We know what the number is going to be, right? It's 3/5. What's its plus or minus sign?
Positive.
Okay. And notice that that equation, 180 minus theta, always applies. So if I know it's actually 180 minus alpha, alpha is 143 degrees. So I get the 37 not only from that formula, but from the concept of reference angles. The reference angle is always the angle made with the x-axis, whether it's in the second, third, or fourth quadrant. Doesn't matter. It's the angle made with the x-axis, and this is always the reference angle, the one I put in parentheses.
Okay.
The reason I do that is because if you're dealing with common ones like 30, 45, and 60 degrees, then these are all positive and you pretty much have them all memorized. If you're dealing with this one, 37 degrees, you're really not dealing with 37. We already know what the sign of it is. It's 3/5.
Okay.
Okay. The only tricky part was converting that linear equation to this triangle.
Yeah.
But remember, slope is rise over run, which is y over x.
Yep.
So when they give you the slope, they're also giving you the tangent of that angle. Every time. Okay, do you need to go through the rest of them, or do you... notice that you don't need your calculator here.
Yeah.
What's the cosine of 143? I assume they want the trig functions of this angle, correct?
Yeah, I think so.
Yeah, not theta. Because otherwise they wouldn't have given you this information here. So what's the cosine of 143? Same as the cosine of what in parentheses?
37.
Look at that triangle. What's cosine of 37? Remember, this is a 37-degree angle right there.
4/5.
Yeah. Positive or negative?
Negative.
And that's not only because all students take calculus, but it's because the x-coordinate is in the negative direction, and the hypotenuse is always positive.
Okay.
You can do the other 4 trig functions. You don't have to use calculator and look up 37 degrees on any of them. Just use those dimensions and figure out you're in the second quadrant.
Yep.
All right.
Okay. So this one, it says solve for all angles theta, where 0 degrees is less than or equal to theta, less than or equal to 360 degrees.
Hold on. 0 is less than theta. So theta is in the unit circle, okay? So one of these have a less than and equal, or both of them?
Yeah, both of them. And then it says tan of theta equals -1.
Where do we know tangent's equal to 1? Which triangle? It's not the 30-60.
Yeah, 45, 45, 90.
So the tangent of 45 would be 1.
Mm-hmm.
So, if I'm solving this, I know the answer is 45 degrees, but the tan of 45 degrees is +1, right?
Mm-hmm.
So what is it? It's not going to be 45. It's going to be the second quadrant equivalent of 45, which is what? First of all, I know this happens in the second and fourth, right?
Yep.
Okay. What's the second quadrant angle that's the same as 45 degrees in the first?
135.
Okay, so that's one of them. What's the fourth angle equivalent of 45 degrees?
-135.
Choose all positive angles for the moment. We have to because of what this says. In other words, a negative angle is outside that domain.
Oh, yeah.
So what's the fourth quadrant angle? Here, the way you do this, here's the second. It's the reverse in the third. And the fourth is the same as the second, only uses 360 minus theta. So what I'm saying is that 360 minus some angle x is equal to 45. What's x?
225 degrees.
Well, move x to the right, 45 to the left. What do you get?
315.
There's the other angle, right there. And
Okay.
this is the way you always want to solve it. Use whatever equation is appropriate for the quadrant you're in.
Mm-hmm.
And just plug in the angle you're trying to figure out for whatever that is, and you'll find the answer.
Okay.
Okay, now, we've got to talk about something else here, because this is significant. There's our answer. Go in your calculator and look up the inverse tan of -1. What's it give you?
The inverse tan of what?
Well, if I'm trying to solve that equation from a calculator, then if tan of theta equals -1, take the inverse tan of both sides and you get theta equals the inverse tan of -1. That's how to look at these. In other words, here's what I'm doing. I'm taking the inverse tan of the left side and I'm taking the inverse tan of the right side. When you take the inverse tan of the tan, you're left with theta.
Yeah.
Theta equals the inverse tan of -1. Your calculator is not going to give you either of those answers.
Yep.
Gave you -45 degrees, correct?
Yep.
There's a reason for that. Your calculator, first of all, can only give you one answer. Can't give you both.
Okay.
Because then it wouldn't be a function. For inverse tan to be a function, inverse tans of positive numbers have to be in first quadrant. Inverse tans of negative numbers have to be in the fourth quadrant. That's
okay.
First and fourth. There are no second and third answers on inverse tan. Inverse sine is first and fourth also. In other words, if I said the inverse sine of 1/2, well, I know that's 30 degrees, right?
Yep.
If I said the inverse sine of -1/2, well, you would think that there is a third and a fourth quadrant angle like that. And there is, but your calculator only gives you the primary one. And the primary one for sine and tangent is first and fourth. And not only that, when they give you the fourth one, they give it to you as a negative angle.
Okay.
Notice that when you got -45 degrees, that is the same as that, right?
Yep.
The 315 is inside of our domain. The -45 is not. So if you're using your calculator to solve for these inverse trig functions, you're frequently going to get an answer that's not inside the unit circle. Because they're usually going to give you a negative angle when they're talking about the fourth quadrant.
Okay, yeah.
Cosine, incidentally, is first and second. In other words, if I have the inverse cosine of √3/2, that is going to be 30 degrees. If I have the inverse cosine of -√3/2, that's not the fourth quadrant, it's the second quadrant angle. So you got to remember, tangent and sine are first and fourth, cosine is first and second.
Okay.
However, that doesn't really apply for solving this problem, because they told us that we had to be between 0 and 360. So they want both quadrant answers. When you're given an equation like this, you can't really solve that with just a calculator. The calculator gives you -45, so you could come up with 315 as an answer, but your calculator never gives you this one. So you have to figure that one out on your own whenever you have these kind of problems, where your angle is in both quadrants. Okay?
Okay.
Good? You had enough for tonight?
Yep.
Okay. I'll talk to you next time.
Okay. Thank you.
Have a good one. Bye-bye.